And here we go. We have liftoff. Propulsion continues to be nominal.
RCPA chamber pressure looks good.
Following up. Roger, planet.
Water towers fly! Yes!
Tango down to nominal.
Flight downside FD off. Bring in FD off. Off. It's orange!
Orange 45! Oh my god! Oh my god!
Decollage.
What is it?
Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This is methane to be igniting with the flare, correct?
Yikes. You good? Sure. We don't need any more of these.
Good morning, space fans, or wherever you may be on planet Earth. Welcome to another NSF stream of Kuiper-2. This is the KA-02 mission, and it is on your screen live from the Space Coast at Space Launch Complex 41 at Cape Canaveral Space Force Station on planet Earth. I'm Gene Rowley for NSF, joined today by an all-star cast this morning to watch this beautiful rocket hopefully take off, as you can see in the upper left-hand corner. In just under 58 minutes is the opening of the window. Joining me today is the one and only Answer All Your Questions, Alex. Alex, good morning, or actually I guess it would be almost good afternoon, right?
Well, I'm sort of always on Eastern time, so it's also a little bit of good morning for me. Yeah, I'm having my coffee here already prepared and everything.
we're always on Eastern time. Pressing the buttons in the back channel there is the one and only Jay Keegan, also Kevin Michael Reed. Thank you guys for being up with us. And we've got two steadfast NSF warriors in the field today. Max has been out there with his cameras for other rocket launches earlier tonight. And we have been able to talk to Sawyer Rosenstein. Sawyer, good morning.
How's it going, Gene? Sorry, I think it may have just gone robot there. Hopefully you can hear me, but it is a beautiful morning as the sun rises. The humidity's starting to die down a touch, and the bugs are out and happy.
Sawyer, I'm just amazed that you guys are out there. This is what we call dedication in the broadcast world. It has got to be a bajillion percent humidity. Bajillion, that's a number. I think he said it was like, I think Max posted it was like 95% humidity this morning, but I mean, you could see the rocket there
earlier. It's still pretty thick, but not as bad.
He's like, I'm cutting through the air. You can see this beautiful rocket on your screen. It's venting, and Alex, they've already got that thing. Is it topped off already with propellant, ready to go here in just under an hour?
Yeah, Atlas 5 and its Centaur upper stage are both fully loaded with propellants and ready for liftoff, but it is not yet time for launch. You see there up on the left upper corner, I guess, of your screen. We're still 56 minutes away for a launch. There's a lot of things that are happening right now. They are in a planned built-in hold into the countdown. They are right now technically at T-4 minutes. They have this sort of T clock where it's like for events and everything, right? And so they are right now there, paused and sort of looking at all of the systems. But so far so good. It doesn't seem like there's been any indication, at least from what Tori Bruno has said or what ULA's official blog post is talking about and everything. Doesn't seem like there's anything that they might be working on today, but you never know, right? The weather also looks fantastic today. I mean, look at that view.
That's a gorgeous shot right there. Morning lunch from Florida is always something. I love the fog down in the little valley there, right on the foreground of the shot. And I want to say good morning to all of you beautiful folks who are joining us here on YouTube and on X and wherever you are watching this stream. Good morning and welcome to this NSF stream for Kuiper-2. So tell me where you are in chat. Let's see if we can, I want to see where you are this morning. All the way from Germany, good morning. And remember, get your questions in at NASASpaceflight. We'll get to as many of them as we can. And most of the comments that are coming in right now are saying, hey, Alex is still awake. And so is Max, and so is Sawyer, and so is pretty much everybody else. Michigan, Detroit, Yosemite Valley, New York, New Zealand, South Carolina, Watching from the Pacific Northwest, my homeland. Lots from Germany, Edinburgh,
Hey, somebody
Norway.
from Spain.
Wow.
Look at that.
Awesome. Well, welcome everybody. And again, get those questions in. Alex, you wanted to say something?
I was gonna say that Max and Sawyer have had it a lot worse than me. At least I was able to get a little of a nap before in between the Starlink and the Kuiper launches. But poor Max and Sawyer they were not able to have any naps. They're troopers.
I see South Africa, India, England, Mississippi, kind of my neck of the woods there. Jeremy, welcome in. Glasgow, Scotland, lots from Scotland. California, my old stomping ground. UK, from the Cape. Tony's from the Cape. Send us some pictures, Tony. Orlando, the Czech Republic. Man, all over the world. Thank you guys so much. We're going to get through some timelines here. And of course, we're going to talk about the weather more with Sawyer. I see I love this shot right here where it's kind of framed by the building on the right, and it's a beautiful zoomed in shot. Guys getting out there doing some great work from a camera perspective. Good morning, NSF. You're still awake. Flippers and 79. Yes, Alex, you're still awake, which we were just talking about. Let's see. A typo. Where is there a typo? 551. No, this configuration.
Yeah, I see
it's 551. It's 511. Yeah, there it is.
Yeah.
So let's talk about that. Let's talk about the 551 configuration. It's a 5-meter wide fairing. It is 5 GEM 63 solid rocket motors, and it is one RL-10A-4-2 engine on the Centaur upper stage, nicknamed the Bruiser. And Alex, this is their most powerful configuration of the Atlas V, right?
Yeah, this is the most powerful configuration. It's got, as you said, the 5-meter wide, also the 5 GEM 63 solid rocket motors, and so it's gonna pack a punch. It always has a single RD-180 engine, but between that RD-180 engine and the 5 solid rocket motors, that's gonna be even more powerful than the Delta IV Heavy, even because when you do the math, it's like, wow, hang on, that's a lot of thrust, and so yeah, it's even more thrust than the Delta IV Heavy. It's gonna be quite a show. I mean, this rocket in this configuration is really a show. And the one, so you see that all the building that is being built. Darn. Okay, so we have here, speaking of the RD-180, I guess, they're doing the fuel fill sequence. That's when they release a little bit of the RP-1 kerosene, as you can see there, into the engine in preparation for the ignition, which won't be for a while, right? But, they need to prepare all of that hardware well ahead of time. But I was going to say, the other building that we were seeing, that's going to be prepared. There we go. Thank you. That's the one that they're going to be using also for Vulcan. So it was being used back in the day for some of the preparations and everything. But now they are reconfiguring it to be able to also help as another vertical integration facility, just like the other one with the ULA logo a little bit down the road, where it's closer to the Atlas. And so one is going to be for the Amazon Kuiper missions on Vulcan, which is the one being worked on the right-hand side there, closer to the camera. The other one in the background, a little bit further, that's going to be for government missions. But Vulcan is even more powerful with the 2B4 engines and also 6 of the GEM 63 XL. Actually, it's not even just regular 63 like the Atlas. Is going to be the XL, which is a lot more powerful. So
can I just point out, by the way, that the name change, I don't like it, because the original name of that building was so sci-fi. It was the Spock, right? It was the Spacecraft and Payload Operations Center, was it?
Yep.
Yeah.
The Spock.
I needed to go back to that. I needed to be the Spock. And it wouldn't be an Atlas launch without Sawyer saying the words GEM 63. Every time we talk about it, Sawyer. I know. Every time we talk about these engines, you seem to be very excited about the solid rocket motors. And I don't know why. Maybe that's just a perception I get, but they're offset. You got 3 on one side and 2 on the other. And as everybody in spaceflight loves to say big words, that would be the asymmetric thrust, which I screwed up there.
They're the gems of the crown.
You beat me to it, Alex.
I'm
But no, I was
sorry.
going to say, part of why I love them is the fact that, again, they're so versatile on the Atlas here. I mean, we've seen it launch with none. In fact, the Kuiper protoflight had only 0. We've seen it launch with 1, with the power slide, 3, 5. So many cool configurations on it. I mean, Vulcan will have 0, 2, 4, and 6, which, I mean, 6 is going to be pretty cool, but it's just something about the power of those and the noise that they make, the rumble that they give off, while not is still really nice.
Wow, people checking in from Thailand. Wow, they're still going over here in chat. Thank you guys for joining in. And also thank you for supporting NSF and everything you do with all of our socials and all of the places that we meet you and you can meet us. And one of the things that we do appreciate is, you know, a lot of people are sharing things. They share and gift Red Team memberships, but they also go out to shop.nasaspaceflight.com. I just got a shipment yesterday. I bought some shorts. I got them fancy shorts from the summer collection. So go check out shop.nasaspaceflight.com. It does help us do what we do. And also sending in questions. I love it when people send in questions because I'm learning stuff just at the exact same time that you guys are learning stuff. So let's get to some questions. Alex, Sawyer, maybe you guys can jump in. So let's go ahead and talk about Kuiper for a minute, right? It's Amazon's competitor. I'll say the C word, competitor. So Starlink, they're making their own satellite for global broadband. They're calling it Kuiper, and they've got a ways to go. They've got to get so many satellites in orbit to keep the frequencies by next year. We'll talk about that a little bit later in the launch. But they are using a ton of other rocket providers. They've got Atlas, they've got New Glenn planned, they've got Falcon 9. So Luca came in this morning with a question at NASA-Spaceflight. When New Glenn's Kuiper? And I think I'm going to throw this one to Alex first. Alex, we've got New Glenn Launch 2 coming up, I guess, a couple of months maybe. When was that one? I missed the announcement.
Yeah, officially it's still sort of targeting middle of August. That's what CEO Dave Limp talked about on X just a couple of weeks ago, if I'm not mistaken. But yeah, that's one of the things that is sort of up in the air. It's not something that we know yet. I think if I were to guess, Blue Origin is still waiting on, you know, flying a few more times with New Glenn, and especially because, you know, the first flight, yeah, it went really great for that second stage. Like, you know, if it had carried a payload, that payload will be a very happy payload. It will have gone to the expected orbit and whatnot. But you kind of want to have a couple more test flights right under the belts, because otherwise, you know, you might still find things that you didn't expect. And so probably maybe like the third or fourth launch, that's when I would expect Kuiper on New Glenn. The same thing could be said, for example, for Vulcan. Vulcan has only had 2 launches, and yet no Kuipers on Vulcan, right? Yes, there's the Atlas that we're seeing right now on screen. It's another of ULA's rockets, right? But it's like, why don't they launch it on Vulcan? Vulcan is having, you know, it has more performance than the Atlas V. It can carry, again, like the B4s are more powerful than the RD-180. It's bigger rocket. It also has the GEM 63 XL and not the regular ones, and it can carry 6 of them. Like, you know, if you can think about that, that's a lot more performance, right, on that rocket. So it can carry more than 27 satellites. We think it's actually like closer to 40. So that's a lot of satellites that it can carry. Why are not they doing that? Well, it's because it only had 2 launches, right? So it's like they want to launch it a little bit more before putting Kuiper satellites on that thing. It's a multi-billion-dollar investment.
Yeah.
So,
and they've
yeah.
got, and we're gonna be seeing, as they ramp up, we're gonna be seeing a lot more Kuiper satellites being sent up. So we'll see what happens. You know, we like to see rockets launch. It's what we do. Let's have some fun this morning. Sawyer, you're out there in the field, and you can see those 4 towers on your screen right now. What are they for? Wrong answers only, please, Sawyer.
The 4 towers are there to act as a parachute or as a net holder, so that when they do smart reuse, that's where they'll actually catch the end. No, Yeah, that's the typical answer we're used to of the
Yeah, I
four
know.
towers being for the lightning protection. It's not the towers themselves that are protection. It is the web of catenary wires that are interwoven between there. It's kind of like makes a box that it flies through. But that way, if lightning were to strike, it hits those towers. The catenary wires then run it away from the rocket and ground it so that it doesn't hit the vehicle. And I'm sure when we see some of Max's prints, you might be able to see that catenary wire lay up there.
And that's a question from Robert Van Rees, who sent that in at NASASpaceflight. But there's more. Alex Severin wants to know, what are the four towers for? Wrong answers only, please, Alex.
They hold awesomeness to help the rocket lift off.
Those are the towers of awesomeness. Those are tower boosters, Severin. They do nothing to help the rocket lift off. As Sawyer said, those are for lightning, guys. We're just having some fun. At NASASpaceflight, get your questions in, and we'll get to as many of those as we can. Chris coming in, becoming a new PadRat member. Thank you for joining us. Lots of people join the community. We're just a bunch of space nerds that love doing what we do and love that you're here with us. So thank you for joining us, Chris, and becoming a PadRat member for NSF. Let's see. A lot of questions. Lots of questions. Let's see. I'm going to say the name wrong. At NASASpaceflight, at least at the Space Coast, how many launch pads have four towers surrounding the rocket? I don't know. Sawyer may actually know. Max will probably know. Also dreamed about licking Booster 16 launch Ship 37 in September. Sawyer, how many? Is that just the standard pad design? Or is that basically up to the company whether they want that type of lightning protection or something else with regards to the lightning towers? Sawyer. He's Robo Sawyer.
I can take it if you want to.
Yeah, go ahead,
Here we go.
Alex.
Now you should be able to hear me.
Sawyer.
Okay, take it away, Sawyer.
More
Sorry about
coffee.
that. Yeah, so we were talking about that during the Starlink this morning. It's actually interesting because it really depends on the needs of the pad. So right now I can think of two, and that's 40 and 41. If you think of 36, where you've got New Glenn, that one has two. If you think of 39A with the fixed service structure, has the one. 39B for SLS has three. So it really comes down to the design of the pad and I guess the rockets that are kind of launching off of it. So off the top of my head, I can think of two are flying today.
It's
And how many launch pads have those? Because we see some, like you said, it really depends on the mission, the company and so on. But it's very common to have those four. It's almost like you said, there's the wires in between them at the top, and it kind of flies through that box. It's a very common design on the Space Coast, but you don't see it at Starbase. You see it more in Florida, and I would guess there's higher probability of lightning. I don't know. Some
Florida
scientists
is known as the
smarter than
lightning
me.
capital of the world.
They figured that out. So
that's true.
I got to talk to a lot of engineers this weekend, so that was a lot of fun. But I realized how dumb I am. When you sit and talk to truly smart people, you realize, like, man, I got a lot of learning to do. Thank you for that question. That was a fun one. Severin, lots of questions from Severin this morning at NASASpaceflight. What fuel does Atlas V use, Alex?
Well, it depends which stage you're talking about. So the first stage, the Atlas booster, it uses kerosene, just like Falcon 9. Although the big difference, I guess, is that Falcon 9 chills down a little bit that kerosene to about -7 degrees, if I'm not mistaken. And so, whereas here on Atlas, it just stays like, at ambient temperature, normal temperatures. And in fact, they loaded way earlier when they rolled it out for the first time for the first launch attempt of this rocket way back like a week and a half ago. They loaded that kerosene already then, and they roll it back to the vertical integration facility, the one right there on the right hand side with a big ULA logo, and they rolled it out again for this second attempt, and it was still there. Like, they just roll it out and back, no problem. It's fairly stable fuel. The second stage uses a much more volatile fuel, if I may say so, and that is liquid hydrogen. So it's a Centaur 3 upper stage, and it's encapsulated sort of inside of that fairing at the bottom there, and it is carrying fuel as it is the other way around. It's carrying liquid hydrogen as its fuel with the RL-10 engine.
Well, let's talk about that because a question came in at NASASpaceflight. Why does Atlas V top its tanks for a while instead of loading the cryogenic propellant closer to T0? And we know that the fuel sequence is complete on this rocket right now at L minus 39 minutes, right, Alex?
Yeah, and
There you go.
this is part of the and now we have a new update.
It
Yeah,
just shifted right where.
talking about the heritage
There we
of
go.
Atlas and whatnot. But yeah, right now they have completed what we were talking about sort of a little bit closer to the beginning, that fuel fill sequence of the RD-180 where they flow a little bit of the kerosene through the lines and whatnot just to fill them up. One of the things that you don't want to is that once you start pumping the kerosene through the engine, you don't want to have things like, say, a bubble on your kerosene lines, for example. And then as you start pumping, that bubble goes into the injector or the or in this case the pre-burner, for example, and then you get an explosion or something like that. You don't want that sort of stuff, so you fill those lines of kerosene already with that kerosene. It's sort of like the engine chill, but of the non-chill down side. Like, it's not chilly. Like, the kerosene doesn't need to be chilled down, but you still want to fill up those areas of the engine precisely to prevent this sort of thing. But yeah, I'll go back to this question, which, to be fair, it's sort of on the same vein. Like, the whole reason is because they can just do it. They can just load it early on, and that sort of lets them sort of flip around the priorities. So you do a lot of the on Falcon 9, you do a lot of the checkouts and loading COPVs, for example, very early on, and then you go and do the propellant load. Here it's a bit, as they load propellant, they do the checkouts, and that's why it takes a little bit longer. It's also like, it's not subcooled propellant, so they can hold, they can keep it there, they can keep topping off. That's essentially what they're doing right now. It's in stable replenishment, as it is called, which means the little bits that they boil off on the hydrogen and the oxygen, then they can replenish it right away as it is still there, as you can see, attached to the ground systems, and so they can just do that.
I love that shot. Great morning camera work, the fog rolling in the low areas, and an Atlas V ready to go on the launch pad. And you're looking at Space Launch Complex 41 from the Space Coast, and this is their bruiser configuration, the 551 5-meter wide fairing, 5 GEM 63s and 1 RL 10A80 engine on the Centaur upper stage. And like, with the stats on Vulcan, I mean, what do they have, like 16 or 14 of them left, something like that? And then they're going to be going to their newer rocket over at ULA. But this is their 165th launch, right, Alex? For ULA?
Yeah. So ULA, ever since it was formed, I believe it was in 2006 when it was formed, this is their 165th launch overall and the second of the year.
And this rocket's carrying 27 Kuiper satellites for Amazon. And technically, as Adrian points out, it's not for Amazon. It's for Jeff Bezos's company. What is it? Kuiper Limited, something or other.
Yeah, I think it's like Kuiper Systems LLC.
Yeah,
it's actually in the description.
Kuiper Systems LLC. Yeah, that's what it is.
Yeah, it sounds bizarre, but keep in mind, Starlink is the same way. So even though we just say it's a Starlink launch, they also have their subsidiary.
Yeah.
Yeah,
I was looking at Go
ahead.
I was looking at Next Spaceflight yesterday. I was kind of looking at it, and I pulled up the launch for today. This was yesterday. And then, like, I was looking at the 3D version. There's a 2D version, a 3D version where you can move the globe around, all kinds of stuff on the app. By the way, if you don't have Next Spaceflight app, which is a part of NSF, it's powered by Flight Club data, and it's actually really cool. I was looking at it yesterday for this launch, and it gives you, the trajectory and all this information. Go download the app. It's really fantastic. But I
just want to point out. Sorry. I was going to say, it's just a huge shout out to Flight Club for the tracking data. Also, a huge shout out to the team of volunteers that works on actually putting in the launch times, the dates, things like that. But yeah, their data is now what allows for that sort of 3D trajectory that you now see with launches
It's
on the app.
so cool. It's so cool. It's to me, it's almost like a video game now. Going to NASASpaceflight, the app, and then like checking all the launches. Because normally I'm looking. You guys know where I'm looking. I'm looking at the same place you guys are looking. But now I just go to NASASpaceflight and be like, oh yeah, okay. And like scheduling. Can I do this one? Can I do that one? Can I work that one? So yeah, get that out. NASASpaceflight. It's very, very cool. Like literally all that information on your fingerprints. At your fingertips. I forgot what my point was going to be. But with all the data, I forgot what was out. It'll come up to me in a few minutes. But you are looking at the Atlas, and we are L34. Now remember, L0 means that's the opening of the window, and we're tracking what's going on with ULA and what's going on in the background, what they're doing in the control room, looking at this rocket. Because, as Alex said, this is their second attempt to launch this one. And one of the questions that came in, why did the first attempt not go? This is Famous V Daily wants to know. Alex, talk us through that, because here we were. It was Adrian, myself, it was Sawyer, and Max, and that first one didn't go. Rockets are hard. They got to make sure everything's going fine. So why did that first one not launch?
Yeah, they had, we were talking before about the engine on the booster, right? One of the things that you also need to do, apart from doing all of the preparations for chill down and fuel fill sequence or whatever, you also need to purge some of the places where you don't want things to go and be essentially bad location. And so what happened on the first attempt was that apparently they had that purge on the RD-180 engine. It's a nitrogen purge. They essentially purge it with the nitrogen, and what appeared is that they had an elevated purge temperature, as they called it, on one of the places of the booster engine, as they call it, the RD-180. And so that is essentially what we were hearing from ULA. Tori Bruno also said something along those lines as well with the gaseous nitrogen purge that they use on the RD-180. So it seemed like it was because of that. They had to roll back Atlas. Sometimes they can work on the rocket at the pad. It's not a big deal because they have fairly good access. But sometimes maybe because of the tooling that is required or the kind of access that they need to the engine or any other parts of the rocket, sometimes rolling back to the VIF, they call it the vertical integration facility. It's somewhat required because of the conditions of where that repair it needs to happen. So that's what they did. They roll it back. They repaired it over the week, and they roll it back out. And here we are, fully fueled Atlas V. Right now, they say they are not working any technical issues. So, knock on wood, in about 31 minutes or so, we're going to see this Atlas V just leaping off the pad with those solid rocket boosters. And hopefully we're going to get a beautiful morning launch here from the Space Coast.
And it really does jump off the pad. Those solid rocket boosters make that sucker move. So Severin, again, another question for Severin at NASASpaceflight. And again, for those of you asking in the chat, can we ask questions? Absolutely. Just at NASASpaceflight, and they'll come to us, and we'll get to as many of them as we can. I can't promise that we'll get to all of them. There's a lot more questions than answers, believe me. But question coming in from Severin at NASASpaceflight. Is there a 552 variant of the Atlas? I'm going to send this one to Sawyer. Sawyer, is there a 552 variant? Severin distinctly remembers Centaur having 2 engines, at least on Vulcan.
Yeah, so in terms of Atlas V, there is never a 552. In fact, the only time that Atlas has had a 2 at the end is what they use for Starliner, which is the N22. So that's no fairing, 2 solids, and then the 2-engine upper stage. I'm sure that option is going to be a bit different for Vulcan, but Atlas has only ever flown in that configuration 3 times.
There you go. Great question. Great answer. Great advice once. Go ahead, Alex.
I was going to say, though, even though it hasn't flown, though, it was planned at one point for launching Dream Chaser. So Dream Chaser is the sort of small winged space plane, right, from Sierra Space now. At the time, it was Sierra Nevada Corporation. But, back in the day, it was supposed to be launched on Atlas V. And for the Atlas V, because it's so heavy, and because it is going to low Earth orbit, they needed the 5 5-2, so the one with the 5 solar rocket boosters. It also needed the 5-meter fairing because it was going to be encapsulated inside of that fairing, and also 2 engines on the upper stage because it was going to be very, very heavy. Now instead, that Dream Chaser spacecraft is launching on Vulcan, so it changed around 2 or 3 years after it was initially announced for Atlas. It was changed over to Vulcan, and it sort of makes sense because it's more powerful, more performance to low Earth orbit, etc., etc. And so that's what they did. And I'm sad that we didn't get Dream Chaser on Atlas 5, or at all, because right now it hasn't launched yet. But whenever it launches, it's going to be on Vulcan. I really wanted to see a 5.5.2 configuration of the Atlas, but fortunately, we are not getting it.
And since you mentioned Dream Chaser, another question that came in at NASASpaceflight: why are there no longer plans for a crewed Dream Chaser? Quote, I wanted a mini shuttle, end quote. Well, okay. Yeah, Sawyer, I'll send this one to you. Why are they changing plans for Dream Chaser?
Well, they put in for a contract for the crewed spaceflight with NASA, and they didn't win. That went to SpaceX and Boeing.
Mm-hmm.
However, they did put in for a cargo contract with it and won. So they are working on the cargo version of Dream Chaser because, well, they're getting the money to do it. So hopefully they will have that completed very soon, and then we'll see after that what they decide to do if variant, which has been discussed.
Alex, in the next 30 seconds, yes or no, Creative Bites wants to know, at NASASpaceflight, will we see a deployment on this flight?
I'm going to guess no, but mainly because of how we didn't see it on the first flight. We saw it, but after the fact, on one of these sort of recap videos that ULA posts out there, and probably because Amazon, they said, yeah, sure, okay, show it, because until then we hadn't seen, we hadn't seen the Kuiper satellites. It was, complicated to really get any images of that.
Well, again, I want to welcome everybody in to Kuiper 2, KA-02 mission with NSF. You're listening to our, I love to say, all-star crew. It's just a bunch of guys that love rockets, and we're glad that you're here with us. And thank you for watching wherever you are. Thank you for tuning in on YouTube or on X or on Popular Science Channel. We love that you're here. Thank you guys so much for being here. And we're going to be answering all the questions and checking out this Atlas V launch, launching 27 Kuiper satellites for Kuiper Company LLC, Kuiper Server. What was it again? I got to look back. Kuiper Systems LLC. Amazon. They're launching the Amazon satellites, going up to a low Earth orbit. And I don't want to take anything away from Alex, who's co-hosting with me today. Going to talk me through the target trajectory for this Atlas V, which in the upper left-hand corner, as you can see, is scheduled to open their launch window in just over 26 minutes.
Yeah, so for today's flight, Atlas V will be flying to the northeast, sort of parallel to the US East Coast. It's going to be heading, there you can see some of those hazard zones, both aerial and marine zones. It's going to fire that RD-180 along with the solar rocket boosters for about roughly a minute and a half or so is when those SRBs will burn out. The booster engine that RD-180 will still burn until at least 4 minutes 23 seconds into the mission. It's a long burner, if you will. And speaking of long burns, the second stage, the Centaur main engine, that RL10 engine, will be firing for 14 minutes, almost 14 minutes, to get these 27 satellites into a roughly 450 kilometer orbit, 51.9 degrees inclination. It's going to go directly to that deployment orbit. And so the deployment will likely happen around, I would say, probably 30 minutes or so. There's no timeline from ULA about that, but the deployment is probably going to happen around that time of the mission. The second stage, the Centaur, though, once those satellites are deployed, it'll perform a deorbit burn. And so it's going to be coming back down over the Pacific Ocean. There you can see that little strip of hazard zone over the Pacific Ocean, where it's going to be coming sort of towards from space. Essentially, it's going to be that re-entry path.
And again, thank you guys for being here with us this morning. We love to watch rockets. You can see on your screen on the right-hand side there, the gorgeous shot. And as we go to a close-up there, you can see the venting from the rocket. It is fully fueled. Weather is apparently a go this morning, and ULA is not tracking any issues with this rocket as we count down to the opening of that window. I want to say thank you to Bob with some support coming in. Thank you so much. When do we expect ULA to match or have a larger manifest than SpaceX at Slick 40? Alex, I think I'm gonna give this one to you, and then we'll go to Sawyer for the next question. But do you expect ULA to match or have a larger manifest than SpaceX?
No, I don't think that will happen. Even if you only count customer missions and instead of Starlink missions, right? Like if you put aside all of the Starlink missions, I think SpaceX will still have a lot more customer missions, mainly because if you compare the number of customer missions that they still have for the year, like if you count the number of customer missions that SpaceX has had so far this year, it's been close to 20, if I'm not mistaken, which means you will probably have to go a few years back to find 20 flights by ULA for customers and whatnot. And so if you remove again Starlink missions, you still have a lot of customers on the schedule for SpaceX. So I don't think it's gonna match or even have a larger manifest. My 2 cents, but yeah.
Bob, great question. Thanks for coming in with that one. Johnny comes in with gifting a Red Team membership. And remember, if you get gifted a membership to NSF in the chat, be sure to say thank you. They're sharing their love of spaceflight and they're joining the community and want to bring more people in. Sawyer, question for you. Where did it go? ULA is talking about smart reuse, right? So Gabriel wanted to know at NASASpaceflight, with Vulcan's smart reuse, will they catch the engines with a barge using a net, or will they let them splash down? How will they pick them up? So talk us through a little bit of what you know. There's that beautiful shot I love. Great work, guys. Talk us through smart reuse with Vulcan going forward.
Yeah, by the way, about the gorgeousness, the sunlight is absolutely perfect with the sunrise.
Beautiful.
The waters are calm. The skies are clear. So yeah, as mentioned, the weather is perfectly go right now. But in terms of smart reuse, so there's not that much that we know yet. There's about it. But what we do know from what we've seen from renders is that it will detach, flip around, and then use what appears to be an inflatable heat shield to kind of slow itself down, get through the thicker parts of the atmosphere, and then parachute itself down. Alex, I'm not sure if we've seen the exact recovery method yet, but I don't think it's going to be a net because SpaceX tried that and very quickly went away from it.
Is that called a balut? The big heat shield thing that inflates?
No, it's just different. Like the balloon is sort of like behind the thing that it's re-entering, right? This is more like it's just it's sort of inflatable, right? But yeah, they're gonna go the same way as SpaceX, but already skipping the net part, which is they're originally they had the helicopter catch, right? But now what they're gonna be doing is it just splashes down, it stays there, and it's inflatable. It's not going to sink as long as it hasn't suffered damage or anything like that. It's going to stay afloat, so they'll just pick it up from there. And a benefit of that is because it is protecting the engine section, the engines will not get wet either. So all of that will still be dry and pretty much ready to go, right? So that's sort of the way that they're going to be doing. They're just pick up the thing floating from the ocean.
Yeah, it'd be interesting to see how they do that. Looks like upper level wins are a go for this Kuiper 2 mission, KA-02. Opening, there's the live update from ULA. Upper level wins have been verified, acceptable for launch, and it looks like they're still looking at 6:54:30. That's pretty precise. AM Eastern Daylight Time, and that's good. Green. I like it. Plutonium 239, thank you. Yeah, go ahead. Let me just thank Plutonium 239. Could New Glenn rocket deliver spacecraft to interplanetary orbit? That's a great question. Could New Glenn, Alex, we're going to give this one to you, and then could New Glenn deliver spacecraft to interplanetary orbit?
Yeah, it's got the performance for that. It just depends on what amount of payload you want to carry, but any rocket, Falcon 9 has done that. Falcon Heavy, Atlas, any rocket. Even at some point there were plans even for Electron to do that. But Electron has carried stuff to lunar orbit with the upper stage. So it just depends how much payload you want to carry.
And you were going to jump in with an update?
I was gonna talk about the adjust thing that they do at ULA because I think it's rather hilarious. But there we can
My
see,
favorite.
yeah, right. Some of the views from ULA. That's a gorgeous shot of the rocket on the pad.
Which is going to be covered in exhaust plumes here in hopefully about 19 minutes. How full? Hi, Mr. ULA spokes guy. How full is the fairing on this rocket? Alan wants to know at NASASpaceflight. How full is the fairing on this rocket? You see the big fairing. How full is that?
Rather
Anyone?
full. So that fairing is a little bit deceiving because it's actually sort of like the payload is only on the tip of that fairing. The rest is where the Centaur 3 upper stage is located because it's a rather skinny upper stage.
There you go.
Thank you. And so there you can see sort of the change from the inner stage that goes to the Atlas booster, and then the 5-meter diameter fairing. And so what happens is that it's also a very thin stainless steel that they use on Centaur, and so it cannot take some of the loads with a 5 solar rocket booster configuration, for example, during Ascent. So what they do is they encapsulate it on the fairing, and so there you can see the bottom half of the fairing encapsulating the Centaur upper stage, and then the other side of the fairing up top, there you can see that is where the satellites are located. Fun fact, if you see that there's like a weird band, there's like a ring at the bottom, right? That is because this version of the 5-meter fairing is the medium length, and what that means is, back in the day when Atlas was fully operational and it was not being phased out and whatnot, it was being marketed with 3 versions of the 5-meter fairing: the short version, the medium length, and the long version. The long version has never flown. The short version has been the most common version of the 5-meter fairing, but the medium length, is actually the same size as the Falcon 9 fairing. And that is, I think it's a neat thing because it just means it is like that because of US Space Force and at the time Air Force conditions to encapsulate their own payloads there. And so what they do is they take the short version of the fairing and then they add like a barrel to it, like another ring of fairing. I added fairing to your fairing so you can have more fairing. That's what they did essentially to be able to have a little bit of a longer fairing. Isn't it nice?
That's a great answer. And, I just want to talk about some of the magic that happens behind the scenes where a question pops up, we start answering it, and then the producers, the guys in the control room are like, oh, I have a picture of that. Boop. I have a picture of that. Boop. And they're doing their magic. So there's a lot of work behind the scenes. It's not just those of us talking. It's not just the guys in the field, but there are a myriad of people working in the background to bring you these launches. And if you want to keep up with all of the launches, be sure to update all of your socials and make sure that all of your notifications are up to speed. So when a new or up to date, when a new launch is rescheduled or scheduled, you'll know immediately, and you can stay right here with us at NSF, and we'll bring you all of that. So there's another update, Alex. Go ahead.
Yeah, so far so good. And now another update. They're pulling. So this is interesting because this is part of the the Bruiser and everything. But so right now they are preparing for the final pull before coming out of the planned hold. So right now, on their operational sort of like their own series of events, they are in a planned hold. Right. That is not. Doesn't mean that the launch time has changed, but their operations, the T clock, right? You can see there on the top left, it says L clock, L minus. That is because it counts down to the launch. The T clock counts down to the end of their countdown. It sort of stops at sort of planned portions and everything. Right now, they are in that point of the count. And what they're going to be doing is polling their operators. They have sort of a control room in Denver, in Colorado. and then they have another in Alabama, and then they're going to be sort of polling those, and then they're going to do the final poll at L minus 7 minutes, essentially 7 minutes to launch at the Cape Canaveral. So hopefully we get to see that in less than 8 minutes. So we'll see what happens.
Yeah, and we'll be bringing that to you when it comes to us. Again, Kuiper KA-02, this is the Kuiper 2 mission. And I did the Kuiper 1 mission, which was actually kind of fun. So I'm now the Kuiper guy. But here in about just over 7 minutes, we should be doing that go, no-go poll. We'll be getting, it's a very orange picture. I do love the low-lying fog. A lot of people are commenting how beautiful it is out there in the morning. Absolutely gorgeous on the Space Coast. Now, Sawyer, I have a question for you. Let's talk about some solid rocket boosters again. Alan wants to know at NASASpaceflight, where do the boosters end up? What happens after those GEM 63s are jettisoned?
Have you heard of artificial reefs? That's what these will end up becoming. So, yeah, once they separate away, they splash down into the ocean and are not recovered. Typically, by that point, again, they'll have burnt all of their bad fuels and stuff. They'll sink to the bottom, and that's one of the few decent things about rockets that ended up at the bottom of the ocean is many fish have taken them and made them their home. So it's not the worst thing. I mean, obviously, a lot more companies now are going for the reusable option because it also saves money. But in particular for Atlas, there are not any parts of it that are reused.
Yep. They go in the drink and become the homes for fish, I guess is another way to put it. Alex, let's just shift to these Kuiper satellites. You know, we're used to talking about Starlinks. We've talked about different variants of Starlinks and how they move around. And a question come in again from Severin at NASASpaceflight. Do Kuiper satellites have the ability to individually adjust their orbits as Starlinks do?
Yeah, they have their own propulsion systems, and so that's one of the things that they are able to use to be able to move around in low Earth orbit. This rocket will place them in a 450-kilometer orbit, but then they need to raise to their own altitude, operational altitude. I believe this one is the lower shell, so there's like a couple of shells that they are targeting. I believe this one is the 590-kilometer shell, so it goes a little bit higher up, right? From there, but either way, like the other shells are also rather close. It's like 610 or something like that kilometers. It's not a huge difference between the shells, but in between all of them, they create a mesh sort of around the globe, and that's what they're trying to get with these many launches that they're trying to hit with Kuiper. And so yeah, they have their own propulsion, of course, because otherwise, if you can imagine things like there's a piece of space junk, for example, if they don't have any propulsion and they are on a course collision with that will be a very bad thing in low Earth orbit. So they have those sort of stuff apart from also being useful for raising their orbits to operational orbit.
Yep, and you may have heard the term Hall effect thruster, by the way. I believe that these are also Hall effect thrusters on these, kind of similar but not the same as the ones used on Starlinks.
Yeah.
And let's keep talking about the satellites because Kusamana comes in with another question at NASASpaceflight. What is, and we'll go around the horn here. Alex, I'll start with you first. What is your opinion of mega constellations, which is what these companies are doing? And again, SpaceX and Kuiper and Amazon, they're not the only ones. There are other satellite broadband providers. Just we talk about SpaceX because they have the most satellites. Kuiper's launching their satellites, and there are going to be a bunch of them before next July. What is your opinion on mega constellations?
Whoa, I mean that's a very it's a very loaded question, I guess. Question. Right? Yeah, right. Well, I mean, it is interesting in the sense that it sort of gives you a lot of benefits with having multiple satellites because you don't have to build like a big one that needs to be sitting way far away, like geo satellites and whatnot. The problem is there's a lot of them up there, right? And if they fail, or if you've got, for example, certain actors that may not play well, but they have their own mega constellations, namely China and whatnot, maybe they don't play as nice, right? With things like astronomy or radio interference and things like that. And so you never know. Thankfully for now, there's not a lot of other satellites out there. But yeah, we'll see what happens when those do get launched en masse. So yeah.
Sawyer, I'll ask you next. What are your thoughts on that? Mega
I mean,
constellations.
I'm torn because on one side, you are bringing internet to people who did not have it. And obviously, internet connectivity is super important in this day and age. It's very important, especially for education and communication. The world is so interconnected right now. It's almost difficult to not have a connection some way to the web. However, as you pointed out, there is the astronomy issues with some of these. I mean, SpaceX has launched over 8,000 Starlink satellites. Many of them have come back down, which is part of the plan for it. And they've improved the reflectivity over time, so it's not as bad, but there's still reflectivity. If you've seen Don Pettit's imagery from the International Space Station, you can see the streak shots that he takes of the stars, all of them intertwined with those Starlink satellites in them. It's great what it's doing, but I mean, I appreciate what these companies are trying to do to lessen the impact on the ground, but there's still an impact.
Yeah, I would have to agree. It's, we love the thought of having global broadband internet, but on the flip side of that, we have to be, and I hate to use the term good stewards, and that's really what we have to be, of that environment. And, as you see the pictures here of this Atlas V in its bruiser configuration on the pad, one of the shots that comes up, this is a beautiful morning flight, and I can't say enough about our amazing photographers that are out there. I love this, just a gorgeous orange shot. And NSF is just blessed beyond measure to have some amazing photographers out there. And you can actually get and support these photographers with the metal prints and the posters at shop.nasaspaceflight.com. I have several of the metal prints from Dee and Max and Jack, Sawyer's got prints out there. All of our photographers, Julia, some of the gorgeous things you can find. These prints, you can, they come either in paper, you can have like a poster version or cardboard version, if you will, but they also have metal prints and they come with hanging material, the hanging, I don't know what it was, the hangers, they come with the stuff to put on the wall. And there's a great shot of the Atlas V. With those GEM 63s that we've been talking about all day. So go out to shop.nasaspaceflight.com, and a portion of that goes to help these photographers get more equipment and get out there and get shots like that on your screen and make it available for us to bring you these rocket launches and bring you these images from basically around the world. It's not just Florida, it's not just Texas, but NSF is all over the world when we can get there. And part of that is shop.nasaspaceflight.com. Plus, there's a bunch of fun stuff out there, patches and stickers and shirts and shorts and pajamas and all kinds of fun stuff. So we're getting ready, guys. We're going to be bringing you that go, no-go poll here in just a minute from ULA. So we're going to be hearing some audio in the background. And this is one of the fun things about ULA launches is we get to hear those controllers.
Status check to proceed with terminal count, Atlas systems, propulsion. Go. Hydraulics. Go. Pneumatics. Go. KA-02. Go. Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. KA-02. Go. LH2. Go. Gas. Go. Electrical systems. Airborne. Go. Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. CCQ. Go. Op support. Go. COM. Go. Umbilical. Go. ECS. Go. Redline monitor. Go. Quality. Go. Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go. Range and weather. Go. Launch director.
You have permission to launch.
Proceeding with the count. ALC verify T0 is set for 10:54:30 Zulu.
Verified.
Polling is complete, and the team is go for launch. From now until liftoff, launch conductor Dylan Rice and the launch team will continue reporting the final steps in today's countdown.
And there you heard that go for launch. ULA is go for launch. I love the go, no-go poll. And you'll see the clock adjust from L0, L minus to a T minus as we get everything adjusted there. And ULA goes through their final checks. But everything is go for this Atlas V 551 configuration to carry these Kuiper satellites to orbit. I love this orange shot. Some of the questions are like, who's out there? on the cameras. Well, I can tell you, Max and Sawyer are out there. And Sawyer, you're seeing this with your calibrated eyeballs. Has it cooled off a little bit, or when the sun comes up, is it starting to get hot to add to that humidity?
I mean, the humidity is getting a little bit better, but the sun is up. The heat is definitely starting, even though it is just before 7 a.m. here. Yeah, I mean, the water is completely flat. There are no clouds in the sky. Weather is greater than 95% chance of go, and it looks like it. So I'm going to finish getting all of my gear set up here, and I will join you after the launch.
Well, thank you for being out there, and we'll talk to you here in probably 5 or 6 minutes as we come to the end of that. And Alex, you talked about that 4-minute hold. You can see T-minus 4 minutes in the upper left-hand corner. That is coming to an end, and we should start seeing things move toward the opening of that window. I love the GEM 63, the bottom of those gigantic solid rocket motors. The hold release you can see there. Yep.
About to release that hold in 6 seconds, hopefully.
T-minus 4 minutes and counting. 3,
there we go.
2, 1, mark.
Bam.
And there we go.
Right on the dot.
We are T-minus 3 minutes and 55 seconds from the launch of this Atlas V. And as you said earlier, this thing just leaps off the pad. And it's because of those GEM 63s, right?
Yeah. Now on these 4 final minutes, it's like everything happens at the same time. It's like they wrap up all of the, pushbacks, as they call them, clearing out all of the lines on the that lead to the Atlas. They have a lot of these things like going into internal power. The FTS is configured for flight, etc., etc. They have all of these things now going into the final few minutes of the count. So things are going to get very active on that rocket and launch pad from here on.
And you notice in the upper left-hand corner, our L- is now T- as ULA has updated their clock and released that 4-minute hold. So here in just over 3 minutes, we should see this Atlas V take off. And again, as you were saying, the upper stage is inside that fairing. It's kind of deceptive because the satellites are at the very top, like you said, and this is their medium-length fairing, which means that the bottom half is that Centaur upper stage.
And it seems like they are already securing those connections. As I said before, the Atlas first stage liquid oxygen replenishment is being secured so that the tank can be pressurized for launch. They're arming also the ground pyrotechnics to release the vehicle. So, all of these little things that need to happen. Prior to the poll, also, Amazon verified that the satellites are in flight configuration, so they are ready to go as well. It's always really good when also the payloads are happy and ready to go. It's not just a rocket. The payloads need to be ready to go as well.
Happy payloads. But Adrian, we need a shirt of happy payloads. I want a happy payload shirt. It'd be a lot of fun. Team, we're under 2 minutes, guys. Who's excited for this launch? Come on. Let's see some Atlas love in the chat. Jeremy, thank you for becoming a Pad Rat member and joining the community of spaceflight nerds here at NSF. You can see the camera angle there. This is the shot that we're going to see from Max, and I assume he's going to be tracking. It's going to be a lot of fun. The launch has been enabled. We are ready to go. You heard a few minutes ago the poll, the go no go poll from ULA, and they are green across the board. Weather is looking good. Upper level winds is good, and we are just over 1 minute from launch. And as we talked about, when this thing goes, it's going to take off the pad real quick. Those solid rocket motors give it a pretty good oomph off the pad. And then we're going to switch to the cameras, the feed from ULA. So we'll see, hopefully, we'll see some tracking shots from Max. We'll see the GEM 63s jettisoned and how they flip away. But again, you got 3 on one side and 2 on the other. So if you got OCD, just go with it. Go with it. It works. As we come up to T-minus 30 seconds for launch. Alex, do we have the, real quick in the next 30 seconds, do we know how much this weighs? We always talk about the weight of the fuel and the vehicle and everything.
Yes, reduced for launch.
Verified.
24. Status check.
Go Atlas.
Here we go.
Go Centaur. Go Kuiper.
Yeah, Adrian, I agree with you. It is a beautiful beast. So here we go. With T-minus 8 seconds, we'll catch you guys on the other side of this Atlas launch. Here's ignition. And away she goes.
Continue to look good. Body rate as expected. Atlas continues right down the center of the range track, 6 miles downrange. Entering our next throttle bucket, preparation for SRB burnout. At this point in flight, Atlas is now half of its original liftoff weight, and engines continue to look good. And max Q, maximum dynamic pressure. And good indication of SRB burnout. Engine response continues to look good. Preparing for SRB jettison. Vehicle throttling back up to full power. And we got good indication of separation of all 5 SRBs. Hydraulics continue to look good.
There to fly off.
That's a great shot. And there you go. Those SRBs, they just
downrange, 37 miles an hour.
Look at that.
We just
And
heard
then away they go.
confirmation of solid rocket booster jettison. These
Yeah, and they flip those boosters off, and then away it goes. And again, did you see how fast that thing took off? I talk about these.
Yeah.
You know how it, as Adrian says, it yeets off the pad, and then you were talking about how fast the pitch over was. Like that thing just launches off the pad and leans over.
Yeah. It doesn't waste any time to already pitch over for to head down range. Should be coming up, as you can see there on that fairing separation. One of the interesting things is that, as this thing was lifting off, it reached Mach 1 34 seconds into the launch.
Activation of the RCS system on the upper stage.
There we go. Preparing already the second
Vehicles
stage.
past the Kármán line, we've exited the Earth's atmosphere.
About a minute and a half.
We get that animation of the
Approaching
Centaur
7,000
stage,
miles
right?
an hour, 120 miles downrange.
There it is.
And we got payload
Fairing
fairing
separation.
jettison, and good indication of CFLR deck jettison. Engine continues to burn nominally.
Hey, I think that's the RCS on the Centaur.
Yeah, you
Already
can see
pulsing.
the RCS. Just barely.
60 seconds.
Still tracking.
Hydraulics
3.5 minutes
flight
T
commentator
plus.
Daniel Brunson just
3.5
called out
minutes.
confirmation of
And there's
There we
that animation we talk about. So we should, here in a few minutes, we're getting, near real time. You can see the animation of the Kuiper satellites. And this is what we were talking about. That Centaur upper stage is the white bit, on the right-hand side, inside the fairing. After that inner stage. So after the first stage burns itself out of fuel, it will separate, and then we'll see that that second stage take over.
Still a few more seconds on that Atlas booster on the RD-180 engine. It's probably already throttling down to maintain acceleration limits, but there should be having a BECO, as they call it, booster engine cutoff, very shortly.
And
Are we still tracking that Atlas?
Responding as expected.
Yeah. Yes. I think. Yeah. I think Sawyer's back of it. Max is still tracking the.
There it is.
Good indication of
BECO.
Centaur separation.
Ooh. Centaur
Nice.
camp.
Start on H2 and O2.
RL10 starting up. And
ignition of Centaur
there it
upper
is.
stage. This will be a
It's actually when
36-second first burn.
when it is the cleanest, when it is actually on, because it's
Signal
hydrogen,
steering
it's
on the
burning
upper stage.
hydrogen.
Center PU set to open loop.
This is
Look at
Atlas
that.
Mission Control at T.
It looks like it moves a lot more than you'd expect. The rockets, they pitch and roll a lot more than you would expect. But again, they're on the, as they say, nominal trajectory toward their orbit. Yeah, there's a shot of Slick 41 adding fog to the fog. Sawyer, we got some of that audio. I know you got it in real time there. What is it? A punch? It's a different sound to me than when you have those solid rocket motors.
I mean, it's a very different sound from something compared to, say, a Falcon 9, where you kind of get a sort of rumble. This one is more of a gut punch in the beginning there. You get that first feel, and then after that, I mean, it's off to the races. It's quite loud, because again, you get more of that sort of crackle from the solids. And so bright this morning, that lit up the sky even more. We talk about night into day. We rarely talk about day into more day.
Yeah. Day into more
I didn't want to
day.
compare it to something else, but it was bright.
Yeah, let's not.
Night to day. Amiga Clone wants to know how many at NASASpaceflight, how many Atlas 5s are left? Alex, that sounds like a question for you.
If I'm not mistaken, it should be 13 after this one. So yeah, 13. I think they have 14 ahead of this launch. And I think it is 13 now, since this already launched.
And then we're going to see some Vulcan rockets. ULA is going to be that. Is that the building there on the right? They're building up the Vulcan. Is that right? The Vulcan. It'll be Vulcan Centaur.
Vulcan will use both, but that's sort of their idea, that they're going to be launching so many Vulcans that they're going to need both buildings. And so the one in the foreground is going to be used for Amazon, and it's called VIV-A, Vertical Integration Facility Amazon. And then they have the regular one, which they're going to be calling it VIV-G, and the G stands for government. So that's going to be for, government missions and Space Force stuff and all that.
And then if we keep talking about that for the Kuiper at NASASpaceflight, Sergey wants to know how many Kuiper launches are planned currently. I know we talk about they have to hit so many launches, so many satellites in orbit by next July. There's a lot of Kuiper launches coming your way, folks. Do we know how many? What is it, 65 or something like that? Alex? For
Kuiper?
Yeah, for Kuiper.
Yeah, there's a lot of launches in different versions of rockets and whatnot. Arianespace, New Glenn. There's also Vulcan, as you mentioned, right? Vulcan has a lot of launches. There's going to be a lot of Kuiper launches ahead. There's 3 at least on Falcon 9 as well. Maybe one might be coming up in the next month or so. We'll see.
Mm-hmm.
But yeah.
And to keep up to date with all of that and everything in space flight, be sure to check out NASASpaceflight.com. Keep your socials up to date everywhere you are. Just look for NSF. We'll meet you where you are. But if you want to get us to send you information, there's a great shot of the VAB. Check out the NSF Weekly newsletter. It goes out every Monday at 7 p.m. Eastern. It covers live schedules for the week, special offers, NSF updates. And it literally just sends you the mail. So follow the newsletter. Get it once a week in your email and stay up to date with everything at NSF and all of those launches that are coming your way from Kuiper and all of the other launch providers, satellite providers. Are you just rolling through some of the beautiful cameras we have to show us why we all need to be in Florida? Look at that plume on the right-hand side from Fleet Cam. Beautiful. It's a gorgeous morning in Florida for a rocket launch.
That's also one of the things as well of solar rocket boosters, that they leave that trail. And so it's not like a regular liquid fueled rocket in general, right?
Mm-hmm.
They leave that sort of trail, and it's kind of nice because it's like, especially when it's a little bit early. Like if I had been perhaps like an hour or 2 earlier in the day, apart from probably not being Max or Sawyer's favorite time of day for today. But it would have left things like no, I think it is noctilucent clouds. The ones that are noctilucent. Yeah. So there are very high up clouds that are created precisely when there's like particles of ice, and so the exhaust from the SRBs sometimes can sort of make some of those clouds apart from the SRBs themselves, and it's really gorgeous most of the times. Yeah, that happens.
When you get a beautiful day like today for an early morning rocket launch, you get everybody out there taking pictures. So Sawyer's got some great shots. Max, of course, was tracking, probably has some amazing shots, but I know Julia is out there as well. And if you want to know, because one of the questions that always comes in, where do you go to watch a rocket launch? There's actually a video. If you can go to YouTube, go to NSF on YouTube. There's a video with Julia. Where to watch a rocket launch. And every time we have Julia on stream, we ask her, like, where are you going to be this time? Where are you going to be this time? Where's the best place to see the launch from? So there's a lot of great secret spots out there. And Julia knows all of them and takes some amazing shots. And again, these photographers put their images out on shop.nasaspaceflight.com, and you can get out there and support them in what they do. That is the VAB, the Vertical Assembly Building, and inside there, vehicle assembly building. Thank you, Sawyer. They're working on the next SLS. Where do we have an update on that one, Alex? What the last thing they did? They got the solid rocket boosters mounted or something like that?
Yeah, so they stacked the solar rocket boosters. They put the core stage in between the solar rocket boosters. They also have put the launch vehicle stage adapter on top. They also have put the ICPS, the interim cryogenic propulsion stage, and that's pretty much it. The reason why they stopped there is because right now the long pole for Artemis 2 is that Orion spacecraft up top, and they're not going to be able to stack it until Orion is fully ready. Now, there's a few months of testing that they need to do and verifications and checkouts and whatnot of the SLS stack as it is right now with the solar rocket boosters, the core stage, and the ICPS upper stage. They need to be thoroughly tested, and all of the checkouts, the connections and things like that need to be also performed in between all the stages. So there's a long summer ahead for those folks working on that. Hopefully maybe Orion is ready by the end of the summer and they can roll it out sort of by the end of the year for launch, hopefully at the beginning of 2026. We'll see.
Yeah, they just updated. Is it beginning first quarter 2026 is when they're looking into that. We've got more questions coming in at NASA Spaceflight. Thanks for you guys for sending in all the questions. But Bob says, I didn't see this, and maybe we'll talk about it just for a second before we get to some of the pictures from the field here. At NASA Spaceflight, can you replay staging? I don't know about that, but we'll talk about this, your next thing. It looked like during staging, they hit each other. Alex, did you see that? I didn't see that. I think that would have been more apparent.
Yeah, I've gone back and there's no contact or any apparent hit or anything. I've not seen any of that. I mean, maybe I just didn't look correctly, but the 3 or 4 seconds that it takes for staging, I did not see any contact or anything.
Yeah, I didn't either. But thank you for sending in that question. We've got some shots from the field that Max, Sawyer, Julia were out there, right, Jay? The one and only Sawyer Rosenstein.
The lighting this morning was so spectacular for this. The reflection on the fairing as well, into the water. I've got some wider shots as well that I'll work on. Members will have a bunch to enjoy from it, but man, the colors this morning were something special.
And you talk about what members see. Capcom members and above get access to our Discord, our member Discord. There's a lot of behind the scenes stuff, and there's a lot of images and footage. And then, of course, sometimes you get to hear what's going on in the background with the producers and so on. So great shot, Sawyer. That looks fantastic. I love the reflection. Julia coming in. Look at that work of art. I love the framed palm trees and the sunrise.
This is what they give you when you're visiting Florida. And then they omit the thunderstorms.
Right.
Yeah, give this to Chris Bergen as the postcard.
That's right.
Yeah.
This is what Florida looks like all the time, Chris. Beautiful shot, Julia. Another one from Julia. Look at that plume you were talking about. And the pitch over. That's a great shot. Pitch over. Right, Alex?
Yep. Yeah, it didn't waste any time to start that kick down range, essentially. Yeah.
Gorgeous.
Really beautiful morning today. Ooh, look at that.
Nice.
This was a 90-second exposure with a filter on it to account for the bright daylight. But again, the reflection in the water, like you're talking about, the pitch over isn't as evident as in Julia's, but that thing flies. Look how far that went in 90 seconds compared to something more like, Falcon 9, which is kind of more, well, less arcy, for lack of a better way to put it.
Yeah.
And also the plume on the outside of it, normally you just get the streak, but because you have the soot coming off those solids, you get that kind of cloud that wraps around it. And that's what I love about Atlas streak shots.
That's a masterful shot. You'll have to show me how to do the 90-second exposures. You guys have experience and knowledge that I will never have, but I'm just going to go and buy this if you put this one on the shop. Beautiful shot, Sawyer. Well done. And by the way, I just want to tell you guys, the rocket's still going. Like, it's still flying. It's still burning its Centaur upper stage. Like,
yeah,
it's
the Centaur is still
uphill.
going.
Yeah, yep. We're showing you these shots. There's fleet cam, but that rocket's still going. So we still have update. What did Tony say? Bruno's Tori Bruno, hot, straight, and normal. So that's good. There's the next update. And there's a fleet cam. You can see one of the Falcon 9s on fleet cam. Is that one? I can't see one.
Look to the right. Look to the right. Look at that. Look all the way to the right, Gene. You see that thing going up?
I do. Oh yeah, there's the rocket. There's the Atlas on the right hand side. I should
just casually,
I should have just looked where it said replay, and I would have known it wasn't a live shot. Nice.
Just
Pay
casually going
Gene.
up there. Ooh, the orange.
My goodness.
It's orange. Look at that.
Wow.
And there's the kick. Look at that. Look at that. Getting out of there.
Adrian was like, it yeets off the pad. We had a discussion this weekend about the difference between yeet and yoink, which we're not going to do here, by the way. You can talk about it in chat. It's orange. This is the one Max was talking about with the.
And yes, this is very much a yeet. Atlas is very much a yeet with the 5 solids in particular. I mean, when we're tracking that, the tripod head, normally, you go up with it. You'll hit the limit, at least for my tripod, about right before Miko. No, this one, 30 seconds in, I'm already at max. Well, not max, but maximum.
Ta-da. Pun star.
Watch the reflection in this, by the way.
That's really great. And
reflection on the wide shots were money today.
The sun played nice. It was just the perfect position. That thing does not mess around. There was a question in chat about the shape of that, the gantry. I don't know what I would call it. Tracking shot. Nice. Some people call it a strung back. Some people call it something else. I'm going to shut up here so we can hear this one roar. Beyond all the technology, all the engineering that goes into it, let's be honest. We're here to see it fly, and we're here to hear it rumble. It's like, yes, can we turn dollars into rocket roar? Because that's what we do. That's what we love. And Jay, this is a Max track. Is this Max or is this Need Pizza? Max, okay. So Max stayed with this one for a long time.
You may also see that, there's like a few chunks of the solar rocket booster material. When it is close to burnout, it's sort of like an engine sputtering, right? And so there's like little chunks of the solar rocket
I was
propellant.
wondering what that was.
Yeah, it does
Didn't
that
they-
every now and then.
Didn't they have one blow the nozzle off recently?
That's a whole different thing. That's a different thing, though.
It's a different chunk.
Yeah, those chunks were a lot earlier, well before any shutdown or anything or burnout.
Yeah,
Yeah.
this is
But-
not an observation.
Yeah. This is normal. Yeah.
Which I'm going to leave you to it with the rest of these replays. I got some things to edit here and some stuff that needs to be taken care of where we're located. But gosh, this was quite a view. Max and I have some winners coming, so please follow the socials. You'll see some really good stuff coming. I got to preview one of
Sawyer,
Max's. It's nice.
Let me just tell you this. Pete J came in at NASASpaceflight. Awesome picture from Sawyer showing day going into more day. So well done out there. Well done.
Thank you. I will take that as a quote now. Of the dumb things I've said, I'm actually okay with that one.
Day into more day. Yeah, Max and Sawyer out there doing just amazing, and Julia out there. We have some amazing photographers. D, Jack. Just absolutely amazing photographers that are out there in the field. And you can see all of their stuff again. All of our socials. They share their own stuff. They share their own photography. They share their experiences at NSF, traveling the world, taking pictures and getting you awesome video shots. And it's because of you. It's because of you that we are able to do this. Alex, what's going on with our Centaur? Did it shut down? Did it reach its orbit?
Yeah,
we
so
knew it
ULA
was
has
burning while we were
confirmed.
talking.
Yeah, ULA has confirmed that the Centaur upper stage has shut down and reached its orbit as planned. And so far so good. Now it's just the turn to start deploying the payloads and getting those very happy customers. Now it's your time, so to speak, right? That sort of handover. There's that update from ULA. Main engine cutoff for MECO is confirmed for the Centaur upper stage. The Atlas V rocket has reached low Earth orbit with Amazon's Kuiper 2 mission. And so those satellites, again, they're going to be deploying over the next few minutes. And then that upper stage, that Centaur upper stage, once those payloads are deployed, it's going to come back down for a disposal over the Pacific Ocean so that, it doesn't become any space junk or anything.
Good. I was going to ask if it goes into a graveyard orbit, but no, it comes down, and there is the splashdown. Expected splashdown of that upper stage in the Pacific Ocean. You can just see Mexico in the upper right-hand corner. But stay out of that if you're on a ship. I get to see, one of the fun things is we get to see the shots on screen with you guys, but Alex and I get to see all the pictures in the background of what's coming, and we're not going to say anything about it, but wow. Just hold on to your socks, people, and be sure to check out all of our great photographers. So let me thank, of course, Sawyer and Max for being out there. Julia was also out there taking photos, getting some video for us. Thank you guys for being on the stream today. And Alex, thank you for being here and answering everybody's questions.
Thank you for having me. 2 back-to-back launches. I like it. I like seeing rockets launch. So, yeah.
I got to do the first KA-01. I've done KA-02. I guess we'll see what happens on KA-03 when it starts going.
Maybe we get a KF-1 soon.
It would be a KF-1, yeah.
That will be Kuiper Falcon 1.
Be sure to keep all of your socials up to date at NSF. We are all everywhere you are. There's too many to list, but just be sure to keep your notifications on YouTube as well. Thank you for joining us on the Popular Science channel. We appreciate you guys being here for another launch. Kevin Michael Reed and Jay Keegan in the production room, pressing buttons, flipping switches, things I have no idea how they work that magic, but they do. Thank you guys so much for all the work you do in the background for all of these NSF streams. For everybody at NSF, I'm Gene Rowley. I appreciate all of you being here, supporting us with your super chats and sending in your questions at NASASpaceflight. Seriously, guys, it's because of you. It's because of our love of rockets why we're here. And we will see you in the next one. And remember, dream big and keep your eyes on the stars. Cheers.
And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up. Roger, planet.
Water towers fly! Yes! Tango down to nominal.
Fighting downside FD off. Bring in FD off. It's orange! Orange 45! Oh my god! Oh my god! Decollage! Put that in the big bag, Jingle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting with the flare, correct?